The universe is full of secrets, and sometimes those secrets keep us from sharing info that could push science forward. Recently, some really powerful telescopes spotted something weird, something that doesn't seem to make sense. It's a cosmic puzzle that has scientists all over scratching their heads. The James Webb Space Telescope has found stuff that makes us rethink the Big Bang Theory. Joel Rand is checking out the telescope's latest discovery, a shocking disappearance of 900 trillion stars. This telescope, which cost $10 billion, has been up in space for a couple of years, and it's already showing us it was worth the money. It's way better than Hubble, giving us views of deep space we've never seen before. Back in July 2022, it started looking at really long wavelengths from faraway galaxies, picking up radiation called redshifted ultraviolet. It's showing us details we never thought possible, areas of space Hubble couldn't even see. But the strangest thing is that James Webb found 900 trillion stars have vanished in space. This makes you wonder, how could that many stars just disappear without a trace? Each new bit of info just makes it more puzzling and worrying. So where did they go? There are a couple of ideas floating around. One is that the stars are still there, but maybe they dimmed out when they died, got hidden by dust, or collapsed into black holes without exploding as supernovas. The other idea is a bit scarier. Maybe the universe is shrinking in a way we can't stop. It's been about 100 years since scientists figured out the universe is getting bigger, and that distant galaxies seem to be moving away from us faster and faster. It's not that the galaxies are physically moving through space, but that space itself is growing, which makes the galaxies move away quicker. This idea has been around since the 1920s, but it's been tweaked recently. About 20 years ago, we learned that this expansion is speeding up. Galaxies are getting farther away from us all the time, so far that we'll never reach them, even if we were going the speed of light. When we see a star whose light took 100 years to reach us, we're seeing it as it was 100 years ago. But when we see a galaxy whose light took 100 million years, it's not just 100 million light-years away. It's even farther. That's because, on a large scale, the expansion of the universe plays a big part. Light takes longer to reach us, and the galaxy is even farther because space is growing. This shows up as a redshift. As light moves through expanding space, it stretches out, changing its wavelength. If the universe wasn't growing, the light's wavelength would stay the same. But because it is growing, the wavelength stretches, causing the light to be redshifted. The redshifts we've seen in distant galaxies tell us the universe is expanding. But we're not just trying to prove the universe is expanding. We're using this info to figure out how the universe has changed over time and what it's made of. When light from a faraway source travels through the expanding universe, its wavelength stretches, causing a redshift. This is more obvious with objects that are farther away because their light has been traveling longer. By measuring the redshift of stuff at different distances and comparing their size and brightness to what we can see, we can figure out how the universe has expanded over time. Also, the way the universe expands depends on what stuff is in it. About 68% of the universe is dark energy, like a cosmological constant. 27% is dark matter, and about 4.9% is protons, neutrons, and electrons. Only 0.1% is neutrinos and antineutrinos, and 0.08% is photons. We haven't found any other exotic stuff like cosmic strings. Knowing what makes up the universe lets us use Einstein's theory of general relativity to guess what will happen to it in the future. We think the universe is mostly dark energy. This means galaxies that aren't held together by gravity will eventually move away from us faster and faster. That expansion is so quick, distant galaxies are becoming unreachable. Even if we could travel at the speed of light, those galaxies are getting farther away all the time. Our observable universe is about 46 billion light-years across. If we assume space has the same number of galaxies everywhere, we can only reach 6% of all the galaxies in the universe. That means, even if we could travel at light speed, we could only explore a tiny bit of it. Also, every second, between 20,000 and 60,000 stars go from reachable to unreachable. Even though the light those stars emitted a second ago will eventually reach us, the light they're emitting now won't. It's kind of sad, but it also reminds us to appreciate every moment. On the bright side, It reminds us that if we ever want to travel beyond our local group of galaxies, which includes Andromeda, the Milky Way, and about 60 smaller galaxies, every second counts. Of the 2 trillion or so galaxies in the universe, we can only reach 6% from the Milky Way, and that number is going down. That means 94% of the galaxies are already out of reach because of the expansion caused by dark energy. As time goes on, every galaxy outside our local group is going to get even farther away. Unless we can figure out how to travel to other groups of galaxies, we're stuck in our local group, and we'll lose the ability to send or receive signals from the rest of the cosmos. The expansion is unstoppable, and our gravity isn't strong enough to fight it. The universe is always expanding, and there's nothing we can do about it. When we think about what this expansion means, it's clear we're living in a special time. This era where we can still see and reach distant cosmic structures is just temporary. Civilizations millions or billions of years from now might find themselves in a universe that seems empty, dark, and without the grand galaxies we see now. Without cosmic background radiation or redshifted light from faraway galaxies, they might not understand how the universe started and changed over time. That's why it's so important to do cosmological research now. The info we collect today might be the only record of the universe's large-scale structure and history. We're like the cosmic historians of our time. Can we outsmart the universe? Even though it seems like we're doomed to isolation because of the expansion, scientists and philosophers are wondering if there's a way to beat it. One idea is that advanced civilizations could create megastructures held together by gravity. These would be huge collections of stars and resources combined into a single system, preserving a part of the universe for the long haul. These structures, called galaxy farms or stellar arcs, would gather resources in a way that resists cosmic isolation. Another idea involves technology we can't even imagine yet, like faster-than-light travel, wormholes, or manipulating space-time. These are just theories, and they might break the laws of physics as we know them. But history shows us that many things we thought were impossible are now certainties. Even using general relativity, we can think about ambitious projects like intergalactic arcs, generational spacecraft designed to reach nearby galaxy clusters before they get too far away. If we start these missions in the next few thousand years, we might still reach galaxies outside our local group. One of the biggest problems with the universe's expansion is that we lose information. As galaxies disappear from view, we also lose the chance to study their structure, how they changed, or even civilizations that might have lived there. In a universe where 94% of all galaxies are already out of reach, we need to preserve knowledge and legacy. Space-based data archives, possibly stored on interstellar probes or artificial satellites in stable spots like Lagrange points, could be the only way for future intelligent beings to learn about the story of the cosmos. Organizations like the Long Now Foundation and Breakthrough Starshot are already working on these ideas on a smaller scale. Building legacies that can last for billions of years might become a new frontier in science and ethics. The fact that most of the universe is slipping away raises deep questions. What's the point of exploring if the universe is going to become cold, dark, and uninhabitable? Is our search for knowledge a way to fight against entropy and isolation? Many people think that understanding the universe is a way of creating meaning. Even in a temporary universe, our curiosity, creativity, and resilience define our place in it. Faced with the vast forces of nature, the act of looking up and asking questions is a uniquely human achievement. But here's the kicker. James Webb found that 900 trillion stars have disappeared into thin air. It makes you wonder how they could just vanish like that. Each new bit of info just makes it even more mysterious and worrying. So where did they go? There are a couple of ideas. One is that the stars are still there, but they're super dim, maybe hidden by dust, or they just turned into black holes without exploding. The other idea is kind of scary. Could be that the universe is disappearing and we can't stop it. We've known for about 100 years that the universe is getting bigger and that galaxies far away seem to be moving away from us faster and faster. It's not that galaxies are moving through space, but that space itself is growing, which makes galaxies move away faster. And it turns out that this expansion is speeding up. Galaxies are getting farther away from us all the time, so they'll eventually be unreachable, even if we were going at the speed of light. When we see a star that's 100 light-years away, we're seeing it as it was 100 years ago. But when we see a galaxy that's 100 million light-years away, it's actually even farther than that. That's because the universe is expanding. The longer it takes light to get to us, the farther away the galaxy is because space is growing. This shows up as a redshift. Light stretches as it goes through expanding space, changing its wavelength. If the universe wasn't getting bigger, the light's wavelength would stay the same. But because it is, the wavelength stretches, making the light redshifted. The big red shifts we've seen in the most distant galaxies prove that the universe is expanding. But we can also use this info to figure out how the universe has changed and what it's made of. When light from a distant source travels through the expanding universe, it stretches, causing a red shift. This is more obvious for things that are farther away. By checking out the red shift of different sources at different distances and comparing their size and brightness to what we can see, we can figure out how the universe has expanded over time. Plus, how the universe expands depends on what stuff is in it. We know that the universe is about 68% dark energy, 27% dark matter, and about 4.9% protons, neutrons, and electrons. Only 0.1% is neutrinos and antineutrinos, and 0.08% is photons. Knowing all this lets us use Einstein's theory of general relativity to guess what will happen to the universe. Turns out that dark energy is running the show. This means that galaxies that aren't held together by gravity will eventually move away faster and faster. As the universe keeps expanding, the distance between us and those galaxies will get bigger, making them seem to move away even faster. And here's the really scary part. At some point, space will be expanding so fast that light leaving our galaxy will never reach a distant galaxy. Even though those galaxies are only 18 billion light-years away, the universe's expansion is still speeding up, and things are getting less dense. Our observable universe is about 46 billion light-years across. If we assume that all parts of space have the same number of galaxies, we can only reach 6% of them. That means that even if we could travel at the speed of light, we could only check out a tiny bit of the universe. Plus, every second, between 20,000 and 60,000 stars go from reachable to unreachable. The light those stars sent out a second ago will get to us, but the light they're sending out now won't. It's a bit disturbing, but it also reminds us to make the most of every moment. If we ever want to travel beyond our local group of galaxies, every second counts. Of the 2 trillion or so galaxies in the universe, we can only reach 6% from the Milky Way, and that number is shrinking. That means that dark energy is causing 94% of the galaxies in our observable universe to be out of reach. As time goes on, every galaxy outside our local group will move farther away. Unless we figure out how to travel to other groups of galaxies, we're stuck in our local group, and we won't be able to send or receive signals from other parts of the cosmos. The universe is expanding like crazy, and our gravity isn't strong enough to stop it. The universe is always getting bigger, and there's really nothing we can do. So, we're living in a special time when we can still see and reach a lot of cosmic structures. But it won't last forever. Civilizations in the future might see a universe that looks empty and dark. They might not be able to understand how the universe started or how it has changed because they won't have access to cosmic background radiation or light from distant galaxies. That's why it's so important to do research now. The info we get now might be the only record of the universe's structure and history. We're like the cosmic archivists of our time. But can we outsmart the universe? Some scientists and philosophers are wondering if we can somehow beat this cosmic expansion. One idea is that advanced civilizations could create megastructures held together by gravity. These would be huge collections of stars and resources in one system, preserving a part of the universe for the long haul. Think galaxy farms or stellar arcs that keep resources together. Another idea involves tech we can't even imagine yet, like faster-than-light travel, wormholes, or messing with spacetime. These are just theories for now, but who knows? Even using what we know now, we could think about building intergalactic arcs, which are spacecraft designed to reach nearby galaxy clusters before they become unreachable. If we start these missions in the next few thousand years, we might still reach galaxies outside our local group. One of the biggest problems with the universe expanding is that we lose info. As galaxies disappear from view, we can't study their structure, how they've changed, or even if there were civilizations there. In a universe where 94% of all galaxies are already out of reach, it's super important to save knowledge. We could create space-based data archives on interstellar probes or satellites in stable areas, so future beings could learn about the cosmos. Organizations like the Long Now Foundation and Breakthrough Starshot are already working on this stuff. Building things that can last billions of years might become a new scientific and ethical goal. The fact that most of the universe is slipping away brings up some big questions. What's the point of exploring if the universe is just going to become cold and empty? Is trying to understand the universe our way of fighting against everything falling apart? A lot of people think that understanding the universe gives our lives meaning. Even if the cosmos is temporary, our curiosity and creativity make us who we are. Even when faced with the huge, unstoppable forces of nature, just looking up and asking questions is a human achievement.